Okay, think about this for a second. How in the world do you drill miles deep into the Earth's crust? I mean, we're talking about powering through solid rock under pressures that would crush a submarine and at insane temperatures. It is a massive engineering challenge, and it all comes down to one incredible and, yeah, often overlooked piece of tech. Let's get into it.
So yeah, how do you actually do it? It's not like you can just push a pipe through the ground, right? You need something right at the very tip that can take an unbelievable beating and just systematically destroy anything and everything in its path. Well, the answer lies in the unsung hero of this whole operation.
And here it is, the drill bit. It is, literally, the tip of the spear. And this thing is not just some chunk of metal. It is a marvel of material science and engineering. It's designed with one single, brutal purpose in mind: to completely obliterate rock deep, deep beneath our feet. To really get how these things work, we've got to break them down to their most basic functions. And honestly, it's a lot simpler than you might think. You know, every single drill bit, no matter how crazy its design looks, really only does two things. Job number one, obviously, is it has to break the rock. But job number two is just as important. It has to allow for drilling fluid to circulate. That fluid is what cleans out the hole, keeps the bit from overheating, and carries all those little rock chips back up to the surface. Both of these jobs are absolutely critical. You can't have one without the other.
Now, when we start talking about how a bit breaks rock, well, that's where things get really, really interesting. Turns out, there isn't just one way to do it. The entire world of drill bit tech is pretty much split into two kind of competing philosophies.
And this is it, right here, the Great Divide. You can either attack the rock with absolute brute force and crush it into little pieces, or you can attack it with precision and shear it away layer by layer. Crushing versus shearing. That is the fundamental choice engineers have to make, and it pretty much dictates everything else about the drilling operation. So let's look at the crushers first.
Roller cone bits. These are the original workhorses of the industry. They are all about applying an immense, focused pressure to just pulverize whatever rock formation they come up against.
The way they work is actually pretty genius. I want you to picture three ridiculously hard meat tenderizers. You know, the spiky kind? Now imagine they're mounted on rolling pins. As the whole bit rotates, these cones just roll along the bottom of the hole, hammering and crushing the rock into tiny fragments. It's a beautifully simple and super effective mechanism.
And this all happens in 4 clear stages. So first, the teeth make contact. Then, the incredible weight pushing down from the drill string forces those teeth into the rock. That creates these little fractures under all that pressure. And finally, as the cones roll forward, their jabbing motion basically scoops out and dislodges those fresh rock chips, clearing a path for the next impact. It's just a constant cycle of impact, crush, and scoop.
And even inside this crusher family, you've got specialists. On one hand, you have milled tooth bits. They have these sharp forged steel teeth that look almost like fangs. They're perfect for just chewing through softer rock, like shale. But for the really hard, abrasive stuff, think granite, engineers switched to TCI bits. These have these little buttons of ultra-hard tungsten carbide pressed right into the cones. They're built for maximum toughness. So crushing is amazing. It's effective, but it's not always the fastest way to get the job done. Which, leads to a pretty natural question. What if you need more speed? What if there's a more, elegant, more efficient way to get through the rock? Oh, there is. Let's talk about the shearers. These are the fixed cutter bits, or as most people know them, diamond bits. These don't rely on impact and crushing at all. Nope. They work on a completely different principle, one that totally revolutionized the industry.
So instead of pulverizing, these bits shear. Okay, new analogy. Think of a high-tech, super industrial strength cheese grater. This bit has no moving parts. Instead, its surface is embedded with these incredibly hard cutters, usually made of synthetic diamond, that literally scrape and shave away layers of the rock as the bit spins.
Now, the idea itself isn't totally new. There were these early drag bits way back in the 1900s. But the real game changer? That came in the early 1980s with the invention of polycrystalline diamond compact cutters. We just call them PDC cutters. These synthetic diamond cutters were so much more durable and efficient, it led to this huge leap in drilling speeds. And then just a few years later, TSP bits came along, which were even better at handling high temperatures. It was a crazy time of innovation.
Now, when you're building one of these PDC bits, you face another big choice. What do you make the body out of?
You can use a steel body, which gives you a ton of flexibility in the design. But the downside is it can wear down faster from all that abrasive drilling fluid. Or you can go with a matrix body, which is made from tungsten carbide powder. It is way more resistant to erosion, but it's also more expensive and a lot more rigid to design. It's a classic engineering trade-off, right? Flexibility versus durability.
Okay, so we've got the crushers, the roller cones, and we've got the shearers, the PDCs. How does an engineer, staring at miles of rock on a geology report, actually decide which one to send downhole?
Well, the choice really boils down to a few key things. Roller cones, with their crushing action, are incredibly versatile and tough. You can use them in almost any kind of rock, usually at lower speeds. PDCs, though, with their shearing action, they absolutely excel in soft to medium-hard rock where you can spin them at much, much higher speeds. And that gives them a massive advantage in pure, raw drilling speed and a much longer lifespan.
So why does any of this matter? What's the takeaway? Well, it's simple. Picking the right bit can literally save a project millions of dollars in time and cost. This isn't just about picking a tool. It's a huge strategic decision based on a deep understanding of geology. At the end of the day, crushing is your go-to for versatility and toughness in tricky rock. Shearing is what you use when you're in consistent rock, and speed is everything. And every single innovation in bit tech directly translates into drilling faster, deeper, and way more efficiently.
It really leaves you with a final thought, though. You know, we've pretty much mastered crushing and shearing, but the challenges are only getting tougher. As we push the boundaries of what materials can do, and as we drill into more extreme environments, what's the next great innovation going to look like? Will it be some kind of hybrid of the two? Or is it going to be something entirely new, something we haven't even imagined yet?